In processes such as aluminum casting, metal processing, non-destructive inspections, and printing on cardboard, the emulsified wastewater generated has a high environmental impact and cannot be discharged without treatment. The treatment is generally entrusted to an industrial waste disposal company, but the measures implemented also include separation and removal using a coagulant and the reduction of the wastewater volume in an evaporator. However, there are problems for these, such as the need for the fine adjustment of agents to suit the concentration of the wastewater and the energy costs for heat sources. Other possible methods include filtering in spiral membranes or hollow fiber membranes, but these have the disadvantage that the flow channel is narrow, so they can easily clog with some types of wastewater. These problems are solved by Matsken's UF membrane oily wastewater treatment system. The UF membrane in this system is an organic membrane with numerous fine pores. It has excellent chemical resistance, and it filters emulsified oil and solids. The tubular membrane has this UF membrane coated on the inside of a porous tube. The flow channel is large, with a diameter of 12.5 millimeters. The wastewater is passed through this channel for treatment. The dead-end filtration system has the wastewater flowing perpendicular to the membrane surface and has the problem that it easily becomes clogged. In contrast, this system uses a cross-flow filtration system in which the wastewater flows horizontally in relation to the membrane surface. There is hardly any accumulation of contaminants, so the cross-flow filtration system does not easily become clogged. The membrane module consists of 18 tubular membranes that are connected in series and housed in a casing. Wastewater is passed through the tubular membrane and filtered. The wastewater is in contact with the membrane for a long period of time, so the separation is very effective. The separated treated water accumulates in the membrane module and is discharged out of the system. Let's look at the process flow in this system. Simply press the Start button on the control panel, and the following flow is all performed automatically. First, wastewater is transferred from the wastewater storage tank to the concentration tank. The wastewater is then sent from the concentration tank to the membrane module and circulates through the system. The treated water that has been separated by the tubular membrane is monitored constantly with a turbidity meter to check that it is clear as it is discharged out of the system. The concentrated wastewater is returned to the concentration tank, and then further concentration is repeated. In this process, the cleaning of the inside of the tubular membrane by sponge balls is performed automatically. The sponge balls flow inside the tubular membrane. The friction from these sponge balls peels off the contaminants, and the turbulent flow caused as the balls pass makes the cleaning effective and maintains the filtration performance. The direction of liquid flow is switched by automatic valves, and the sponge balls go backwards and forwards between the ball catchers at each end of the membrane module. The concentration is repeated in this way, and when the liquid level falls to the set level, the concentrated liquid is discharged to the concentrated liquid storage tank. The flow channel is then switched from the concentration line to the cleaning line by an automatic valve, and circulation cleaning is performed automatically. There is also effective cleaning performed by the sponge balls at this time. This completes one batch process. Once wastewater has accumulated in the wastewater storage tank, it is automatically transferred to the concentration tank and then treated again. This UF membrane treatment makes it possible to separate and remove the oil and solids from emulsified wastewater to obtain clear, treated water. The control panel of this equipment has a touch panel to make it easy to operate the device and to check the operational status. Various confirmation screens can be selected from the main menu screen. Let's look at the operation screen, flow screen, and trend graph. On the operation screen, it is possible to check aspects such as the operation settings, the automatic operation process, and the water level in each tank. On the flow screen, it is possible to check the operational status. The trend graph shows data such as the trends in the water level of the concentration tank and the flow rate of the treated water. This data is recorded and can be transferred to a PC or other device. These are some results of customer installations. This is a result of the treatment of wastewater containing die-casting lubricant. Compared to evaporators, there is no fuel consumed, so energy costs were significantly reduced. There is also no need to perform the expensive routine maintenance that is required for evaporators. This is a result of the treatment of wastewater containing water-soluble cutting fluid. The volume of wastewater to be sent out to an industrial waste disposal company was greatly reduced, which contributes to a reduction of running costs. The advanced treatment specifications include the addition of an RO membrane for decolorization and to further reduce COD. This is a result of the treatment of the wastewater from cleaning. The constant filtering of the cleaning solutions in the tank with the UF membrane means that the increase in the oil concentration is suppressed, and the cleaning performance is maintained over a long period. The level of contamination of the cleaning fluid is suppressed, so the length of the use of the cleaning solutions before replacement is greatly extended. This reduces the frequency of the work to replace the fluid and the cost of disposing of it. This is a result of the treatment of can processing coolant wastewater. The removal of coolant components in the UF membrane processing reduces the load on the comprehensive wastewater treatment facility. This has prolonged the life of the activated carbon and reduced replacement costs. This is a result of the treatment of wastewater from the cleaning of a penetrant, flaw detection material. The UF membrane equipment installed in the construction of the new plant reduces the use of labor, energy, and space, and the volume of wastewater. It is possible to keep the plant clean. This is a result of the treatment of the ink wastewater generated when cleaning dies off printing plates. It has reduced the burden on the workers from the previous treatment using coagulant. These are the features of this system. Treatment performance. It is possible to treat highly concentrated wastewater and separate it to obtain clear, treated water. A tubular membrane system is used to suppress clogging. Automatic ball cleaning maintains the separation capability. Ease of working. The operation is performed automatically, so unmanned overnight operation is possible. The replenishment of chemicals is not necessary, and the system is easy to inspect and maintain. Equipment specifications. The equipment realizes energy-saving operation and a space-saving design. It is also possible to install additional membrane modules, so an increase in the volume of wastewater can be easily handled. In addition, various options are offered to meet the requirements of individual sites. RO membranes are also available for advanced processing.